So for some time now, I've been collecting these dreadful little radioactive pellets of americium from smoke alarms. I am even blessed enough to have sourced myself a delicious 80 microcuries of americium from a very old smoke alarm. Now, as any good mad scientist would, I sleep with him right under my pillow. The only downside to this is that he releases crap tons of radiation. So the isotope used in smoke alarms is called americium-241. It has 95 protons and 146 neutrons. Now, this guy can undergo an alpha decay, which is basically where the nucleus ejects 2 neutrons and 2 protons. And this sort of takes the form of a helium nucleus, but with a +2 charge. So the nice thing about alpha decay is that alpha particles aren't actually that penetrative, mostly because of that 2+ charge that they have. So a few centimeters of air or even a sheet of paper will block them. So why then is the Geiger still reading even when I put a sheet of paper over this guy? Not to mention the thin layer of plastic around it in this baggie, or the thick layer of plastic on the small sample holder I have here. So, to shed some light on this, let's take a look at the decay equation. On the left side, you can see we've got our americium-241, and at a half-life of around 430 years, he will decay into neptunium-237. You see, he also produces our alpha particle. We can see that there, mass of 4, 2 protons, and a +2 charge. However, there's also something on the right side here, and this is our gamma radiation. And this is the energy that that gamma particle has. So, along with alpha, the other 2 more common types of radiation are beta, which is a high-speed, high-energy electron, or gamma, which is just a high-energy photon, like X-rays or light. So, each of these radiation types has a different penetrating power. Alpha is the weakest, as mentioned before, he's blocked by paper. Then beta, just being an electron, only having a -1 charge, interacts only slightly. So he will get through paper, but generally he can be blocked with a small sheet of metal, like aluminium. Gamma, being just a high-energy photon, is the least interactive, and so he'll penetrate through most things. You'll need a fair bit of lead to attenuate him. So, now you see why lead is the material of choice. I'm going to load up some lead into this pot. One of these is this old lead pig, which I'm going to remelt. So, I'm actually using a hot plate here, and this hot plate is really for SMT soldering. It's not really there to melt metal. Oh, actually, sorry, I just realized that's literally what it's designed to do. Okay, we're doing soldering, but on a larger scale. Sure, let's go with that. Anyway, I'm using a blowtorch here just to help the process along. Oh, it's just gone out, never mind. But generally this process can take anywhere between 10 and 20 minutes as I futilely attempt to melt this lead here. Oh, look at that go. So here I'm adding in a big circle of lead, which I guess I got off the bottom of this pot from the last time. That's actually quite fun to watch. It's quite mesmerizing. Do I not have a glove on? Oh, I guess I'm only wearing one on one hand. Alright, I've got the wiggle going on. This is a tried and true method for melting lead. Just wiggling back and forth. Great. Okay, so we're all molten here. Just trying to get all the slag off, which is all the oxides and other crap that floats to the surface of the lead. Just running a spoon over it tends to collect it. So this is what I'm thinking for the cast. I'm going to take this aluminium can, which is about the outside diameter size that I want for the lead pig, and I'm just going to cut this top lip off. There it is. That is going to make for our cast. So I was slightly concerned that having that just empty aluminium can on the table would be a problem. I mean, it might burn the table, or it might just deform a lot. So I thought maybe I'm going to stick it in some bentonite clay. just to hold it in place a little bit. So there we go, all together. This is going to act as the negative. So he's going to be this is going to be the inside size. I will just have to hold this roughly in the right place. Ooh. So I've probably done this in a slightly stupid way, but basically I'm going to have to heat this can up and the rod just to remove any humidity and to try and get things up to lead temperature. It's very heavy. There we go. Now if I just stick this guy in, that's not enough. Okay, probably needs all the lead, to be honest. Alright, that's good. Now if I stick this guy in, should be able to offset him about to the top. Hopefully I get that in the right place. Looks good to me. That was quite fun. We'll see how it turned out in a minute. Alright, looks kind of like it's been somewhat successful. I might just rapidly cool this off now. The aluminium is really hot. I could hardly hold the damn thing. Alright, let's quench this guy. No surprise there. Like that. By the way, it's quite important to make sure that any cast like this has set for long enough so that the insides have all solidified. Because if there's some molten lead inside of this guy and you dip them into water, it can cause some slightly nasty things. Generally, just don't be as impatient as I am. See? So after removing the thin aluminium outer layer from the can, I was left with another issue. The aluminium bar stock that I used evidently had a small flare on the end, and so the cast could not be pulled off of it with great ease. He's definitely moving. I don't think it's just the lead smushing. The whole thing is coming off. Future Lex here. It really was just the lead smushing. It was not coming off at all. And sadly, I did actually have to take a drill and drill a hole right underneath that stock so that I could bump it out with a bit of metal. Holy shit, that actually fucking worked. So I did make a bit of a feeble attempt to hammer out all of that deformation from before. Sort of cleaned it up, but not as much as I would have liked. Alright, here we are, the final test. So here I am checking the sample without cover, and would you look at that? Basically a full reduction of radiation. Amazing. Alright, all done. Here he is. I've given him a little paint job, cleaned him up just a bit, and the sample still fits really nicely in here. I've also gone ahead and made him a little very crappy lid out of just some lead sheet that I had. And if I pop that guy in there, now he really is contained. Ironically, that hole at the bottom did come to bite me. He does leak very slightly, but for the most part, job done. By the way, I don't actually sleep with him under my pillow, although I could now, technically, but that's still a bad idea. Potentially in future, I might revisit this. I probably will revisit this. This guy's pretty clunky, and his walls are way too thick. Mainly as I didn't have a very good cast, but I managed to actually source some really nice tins here, and these look to be a way better diameter. So you can see there, that would be perfect. I will make a video on it, obviously, but it would be useful to have a better one.